All right. Hello. Today I'm gonna teach you something very special that I learned today, and it has a lot to do with one of these. That is not half a how do you spell it? Sandwich is not a sandwich. No, that is a right angle triangle. Oops, you can tell because down here we have an angle, and that angle is 90 degrees. There you go, 90 degrees. Now, all of these sides that you see here, these all have special names, and even some of our corners can have special names as well. So, right here, we already listed, that's the right angle. Down here, let's choose down here. You can choose either one of these corners when you want to do this, but I'm going to choose down here, and that there, we're going to label that as theta. And theta looks like this. It kind of looks like a little pill, and it's a Greek symbol, I believe. Yeah, I think so. That is theta. Theta. That is theta. Right there. And so theta, for the rest of this, we're going to take the perspective of theta. So you might even say that theta is like an eyeball there. That's not a very good eyeball, is it? We can draw a better eyeball if we just do that. Or maybe this? I don't know. I've never drawn. I didn't practice this, so now I'm kind of curious to see. That's an alright eyeball. We'll deal with that. So it's kind of like, if you're peeking in, that's where you're peeking in from. That's theta. And we take theta's perspective. So, since we're taking the perspective of theta, what do you think we might call this line right here? What do you think we might call that line? Well, it is the opposite of theta. So I don't think, but mathematicians think we should call it the opposite. We should call that the opposite side. I think that's a pretty good name for it. All right. And so what have we got? What have we got here? Okay, so we've taken the perspective of theta. Let's jump. Oh, well, actually, we'll keep the perspective of theta, but now theta is looking over here at this right angle. Theta's taking a look at that, and theta's thinking, maybe I can use that to name something. And theta's taking a look, theta's taking a look at where the right angle is pointing, and the right angle is pointing up here. And this one's got a really tricky name. This one is the hypotenuse. Hypotenuse? Is that it? Is that how you spell it? I don't know. You can remember that because it's like hippo, like hippopotamus. That's what I always heard in school. Not hypotenuse, but hippopotamus. And I never remembered it. And that's why I'm a 23-year-old learning it today. Am I 23? Yeah, I'm 23. That's our hypotenuse. So we know it's our hypotenuse because it's across from our right angle. It's also going to be our biggest side. So if we draw another right angle, and we could draw it like this, then we could draw our hypotenuse down here. Down here, that's our little tiny right angle. And then we can put theta there, or there, or down there. And as you can see, there are two lines here. They intersect, so we have a straight line going down, and they look very similar. But because this line here is slightly curved, or not curved, but slightly diagonal, it's going to be a longer line because it's got further to travel than that line. And maybe I can even show you that if we now place them next to each other. There you go. You can see that it is ever so slightly longer. Okay, and so that there is our hypotenuse. What haven't we named? Who's left out? Well, Mr. Grumpy Line over here. Look at him. He doesn't look very happy, does he? Oops, I didn't know that's what that did. No. How do I make him Mr. Grumpy Line with his tongue sticking out? What do we think we call this one? Well, remember we're taking the perspective of theta. So this one is next to theta. And so we called this line here the adjacent. That's the adjacent line right there. And now that we know that, and again, that's the adjacent line because it's next to theta. But if theta was up here, say if this was our eyeball here, then the adjacent line would be this one here. It would be the opposite would become the adjacent, and the adjacent would become the opposite because it is opposite to our new theta. But we'll keep theta down here. Now, this is wonderful. This is great. What can we do with this? Well, you ask what we can do with this. Let me tell you something very special that I actually don't really understand. So, and it's going to sound like I'm cursing you here, but I swear to God I'm not. Ka, doa, sokotoa. What What is SOHCAHTOA? SOHCAHTOA is a mnemonic, so it helps us remember something that is a bit tricky to remember. And in this case, it helps us remember 3 different equations that all relate to each other. And they all relate to our right angle triangle down here. So means, what does so mean? What do you think it means if we've just written this? Yeah. Well, so, that S there, that means sine, and then OH. Well, that means sine is equal to the opposite, so that's this line here, opposite over our hypotenuse. And we'll write hippo for short. Keep it nice as short and sweet. Okay, so that's so. What is sine? What is sine, do you think? What does that mean? This is a real question. I actually don't know what sine means. I actually only learned this today. I'm not kidding at all. Ka. What does ka mean in our SOHCAHTOA? Well, we're going to see here. We don't know what that C means, so I'll tell you what that means. That means cosine. And come on, running out of space here. Can I just I don't know if this will work. Oh, that's nice. That's good. Sweet. Oh no, come back. We'll move all of these. Come with me. Oh, what? Why did all of opposite not come? Oh, it's because it's not actually highlighted. Sorry, this is so professional of me. I want to take the arrow. Come back, arrow. There we go. Okay. Arrow is back. Crisis averted. Cosine. What's that mean? What's that? Well, cosine is equal to, and I bet you can guess it. We look at our opposite, our hypotenuse, and adjacent. The only one that starts with an A is adjacent. So we can call that adjacent over our hypotenuse, hippo. And then, again, I don't know what cosine means. And then we can finish off with TOA, which is covered by this bar up here that I don't actually know how to get rid of. Laser pointer. Textite. Mermaid Trixelador. I don't know what any of that means. TOA. So that is our tangent. T-A-N. And it can be shortened to tan. This can be, so actually, you can shorten these to sin, cos, and tan. But I'm telling you the whole numbers, all names today, just because I'm being very sweet. Tangent is equal to, and you know the deal by now, it is our opposite over our adjacent. Alright, so that's practically what I know. But I do know a little bit more. I do know a little bit more that I can give to you right now, that I can gift to you as a thank you for watching. And that is a little bit about what these mean. Just a little bit. I'm really liking the way that this drawing is looking, so I don't really want to get rid of it, and changing colors is very difficult with this app. Go away, my board. Click. There we go. So we're gonna do a calculation here. We're gonna calculate. So that's 90 degrees there. Actually, you know what's really interesting? Trying to find, you know what I've just realized? I think I've just realized something really bad. I've just realized something really bad. I've misled you. I've misled you this whole time. You were tricked. I honestly probably shouldn't upload this video because it would be immoral if someone only watched the start, which I assume they will. That's not theta. That's not theta. Theta is actually up here. That is theta. And that's our observation angle, and we can call our observation angle. Technically, we could call it theta, but it's not theta. Our observation angle, we call it angle 1. Oh, wait, that's like a lesser than. I can never remember how to draw the angle symbol. It's like that. So we can call that angle A, actually. Angle A is our observation angle. This is getting real messy now. So theta should be up there. And honestly, if I'm being honest, theta's taken up a lot of space. Theta's kind of big. So because theta's just a bit big for its britches, I'm gonna maybe knock it down a peg. And also I'm gonna delete this arrow. Come with me, theta. Make you smaller. And actually, let's just put you up there. And get rid of your brother. Okay, so this is angle. That's what that means. And that's theta. Fuck me. No, and don't show this in class, by the way. A. Theta. What do we do now? What am I trying to do again? Okay, let's assign some values. So, theta equals unknown. Theta, we don't know what theta means. This angle here, 90 degrees, of course, because it's the right angle. And we'll call this angle here 40 degrees because that's the second number I thought of. and I've never done it before. So our job is to work out, what does theta equal? This seems really hard, right? And actually, it kind of has nothing to do with what we've been talking about at all. So something important to know is that each of these angles, theta and the right angle and angle A, all put together will give you a little thing. So we could write that equation as theta. I need to explain something. All of the angles in this triangle and in any triangle will always add up to triangle. That's a horrible triangle, but it works. Equals triangle angles. There we go. Oh, it's like the Triforce equals 180 degrees. It will always equal 180 degrees, which, by the way, is half of a circle. Is that the Pepsi logo? Also, if you're wondering, a 90-degree angle, so this angle here, we could copy this angle. Give me this angle. Give me. Take my angle. Expand it quite badly. Expand it very badly. And actually, it's not actually, you know what, I'm just going to get rid of that and draw a new angle. 90 degrees in a circle, and that's why that's a 90 degrees, and that's 180, and then a whole circle is 360 degrees, and that's why if you shoot someone in the head with a gun that has a scope, usually, and it's usually a sniper, you kind of want it to be a sniper, guess, I don't know, how else would I make this more snipery if I gave it like a little thing there? Yeah, so if you kill someone with a sniper, kill them dead, and that's the bullet hole, actually, they got blood coming out of the back of their head because you shot them with this sniper, and if you were, before you shot them with the sniper, to jump off a ledge, and I assume the ledge would look, well, yeah, I guess the ledge would look kind of like that. Hello? And then if you say you're here, and you jump off, and at that point, you're exerting force moving that way, and you jump off, and then, I don't know, you like spin around, you rad. It's actually, when you spin around, that's called rad in physics. So this would be called rad, and then you move down at what? G, gravity equals 9 point... Oh, what is it? What is gravity? What does gravity equal? I think it's 9.8. I think it's 9.8. I'm gonna go 9. So you're moving down at 9.8, and that's meters a second. So you're moving down, and you're being rad. You're being rad, which means that you're spinning. So you're spinning, but you actually because it's a 360, you're actually only spinning once over the course of that, and then you land here, and you've got to have someone to land. So you land here with your sniper, and you shoot this person in the head, kill them dead. That is a 360 no scope, because you didn't activate your scope when you were down here. Now, this is not normally the type of thing that is encouraged in battle. For example, if you're in Gallipoli or something, if you're in Gallipoli and you no-scope someone, while I'm sure everyone would be like, wow, that's really cool, or they'd probably say, wow, that's really rad, they probably wouldn't be that impressed. But if you do it in COD, which is different to COS, that actually stands for Call of Duty, COD, Call of Duty, then yeah, that is actually quite rad. Although G in COD does not equal 9.8 ms, and it especially doesn't equal that if you're playing on like a novelty map like the moon, or if you've got gravity, like a gravity hack on, or anything like that, or maybe the server that you're on has some sort of gravity thing or something. I don't know. So yeah, we've got the what did we have again? What were we doing? Let's calculate sine, I think. No, theta. We're still trying to find theta. Okay, can I zoom out? Can I get more space somehow? Hey, great. Oh, that's really good. Okay, no, let me zoom out. All right, is there a hand? How do I move? Do I scroll? Okay, well, now we got some more room. All right, and now we can see Toa again, which is great. We're calculating this. We're calculating theta, which is not down there, it is up here. Okay, so we now know that 360 is half of a circle. Oh, sorry, 360 is a total circle. 180 is half of that circle. And a triangle, or all of the angles in a triangle, will always equal half of a circle. Okay, sniff. Which means that if we've got another circle here, and we've got 90 taken up already, so we can do that. We shade 90% of the circle, and then what about 40%? I don't know, maybe there. And so we've still got a bit here that we need to fill in before we can say that we're at 180. So we need to find out what theta is. So in general, the general rule of thumb is, and let's get rid of all of that, and let's make that theta. Theta equals your right angle and your observation angle. So that's angle A in our case. Except, sorry, I forgot, is theta equals 180, and maybe we'll do this somewhere else because this is a bit janky, isn't it? We'll do it down here. Theta equals 180 minus that 90, but in this case we could write right angle, we could write that, but I'm just going to write 90 for simplicity, and technically we could write degrees, but I don't want to, and then we'll minus 40, and so then we've got theta equals 180 minus 90 minus 40. Plug that into your calculator because you have to practice for your physics exam. 180 minus 90 minus 40 equals 50. That's right, baby. That's right. Which means theta equals 50. Now you might be asking me, Kelton, what does this have to do with cosine and tangent? And it has nothing to do with those. That is not to do with those at all. I don't know why you'd make that assumption. But you know what? You've stuck around for so long now that I'll let you in on a little secret. So let's assign some values to our sides here. And for the sake of argument, I don't know if this will work. Actually, now that I think of it, I don't think it will. I think I would have to do it in some weird way. Oh well, let's call this 40. We'll give it the same things as these. We'll call that side 40, and we know this side's got to be bigger, so we'll call it 50. So now we want to figure out the ratio. We want a ratio adjacent. Ratio, so grumpy. Such a grumpy part of the triangle. Kind of cringe, NGL. So we just want to cancel it. So how do we... That's a 2. How do we cancel adjacent? Which I'm going to write like this. It's actually ratio. How do we ratio it? We're not necessarily canceling it. You know, maybe it's just a bad take. It's a bad take. It wasn't like it didn't, burn down a mosque or anything. It's Jesus Christ. It's not that horrible. Like, it just said some kind of off remarks about a niche group on Twitter that it didn't understand yet. So we'll give it a pass for this one, and we'll just ratio the tweet instead of actually ruining their life. What do we do? How do we find that? Aha! Now you know. Now you've come back here. So, what do we got? We got the opposite and the hypotenuse. Is it hippo? That's sine. So, what is opposite hippo? Opposite is here, 40. Hippo is 50. What is 40 divided by 50? 4 divided by 50 equals 0.8. Now at this point, I'm pretty sure that I meant to times this somehow, or times it by something, but I don't know what to times it by, because that can't be 80. 40, 50, and if we times it by 10, wait a second, times 10. Yeah, no, that's just 8. That's just 8. We couldn't times it by 10. Couldn't be 8. It could be 80. I don't know what that means. That? I don't know. However, that is probably the ratio. We probably did ratio correctly here. Oh, you've got a body now. Oh, look. And then you could type on a little keyboard, and then, I don't like the legs. We'll draw a desk instead. Maybe not. We could draw a chair. Whoop. Yeah, this is good. Legs come off the chair. I like it being little baby legs. That's pretty good. And then, right here we got the desk. And then that can be like a little webcam. And then maybe we got like a screen there or something somehow. And then the keyboard they're typing on. There we go. So that's them. They're making their tweets, and we have now totally ratioed them. But you know what? at the end of the day, everyone gets ratioed, and you're welcome to set this as your wallpaper background if you'd like, if that'll help you remember all of this. Again, I don't know what sine or cosine or tangent mean. I just know that you can get some sort of ratio from them, and that ratio probably should equal the adjacent somehow, but I don't know how to make that. I don't know how to make that the adjacent. So I'm gonna go figure that out, and you will probably just get this video uncut. Like, I'm not gonna add in how I find the adjacent. That's your task. That's your homework. Homework equals find the adjacent, which, to be clear, is different from theta, which, to be also very clear, is different from what I have labeled angle A. Also, angle A could be angle X or angle little picture of a dog. That's more of an octopus or like a satellite. It doesn't have to be angle A, is what I'm trying to say. Everything else is, you know, theta could be there, or angle A could be there or there. Angle A or theta can't be here because that's always going to be a right angle. Although you can have a triangle that's, you know, the right angle is up there. Or you could have a triangle where the right angle, and excuse my drawing here, is there. Or you could have a right angle that's there. You know, right angles that, they can be anywhere. They're tricky. They're very tricky. That's an equilateral. That's an equilateral triangle. I'll try again. There we go. Oops. Yeah, this is pretty hard. This is pretty tricky for my brain. But that's the right angle. Kind of looks like a pyramid. And I think there's like a trick, like if you draw... Oh yeah, so if you like draw down there, then you make a pyramid. But also you should kind of have this going down or something. I don't know. Alright, anyway, that was my job application for Khan Academy. Thank you so much for watching. See you next week.